Assalamu alaikum, dear students. Today we will discuss about the Milliken's oil droplet method. Students, Milliken's oil droplet method or Milliken's oil droplet experiment was used by Milliken in 1909 in order to calculate the charge on an electron. Students, he used an apparatus whose construction is this. Students, the instrument being used by the Millikens was composed of a large metallic chamber fitted with two electrodes, and upper electrode having a hole in it named as A and a lower electrode as A prime. These electrodes were connected externally to the source of voltage. The positive terminal of the external circuit was connected to the upper electrode A, and the upper electrode A was named as anode. The negative terminal of the battery was connected to the lower electrode A prime, and it is named as cathode. The space or cavity or vacuum between these two electrodes was filled with gas, or it was simply a vacuum. There was a source of observing all these happenings or changes or reactions between these two electrodes via microscope. There was a window from which source of X-rays was also provided, and there was an atomizer filled with oil. That's why it is known as oil droplet experiment. Now students, we will discuss about the working of Milliken's experiment. Students, first of all, Milliken developed a fine stream of oil droplets. A fine stream of oil droplets. Stream of oil droplets. One of the droplets was observed at a specific time interval by using the microscope. Initially, when the droplet moved under the action of gravity in the absence of applied electric field, the droplet fell down under the action of gravity and moved with the velocity v1, which was directly proportional to its weight. Initially, he sprayed or he generated a fine stream of oil droplets, and droplets after passing through this hole fell down under the action of its weight or under the action of gravity in the absence of applied electric field. He observed its velocity as v1 and named it or measured it as v is directly related to mg. This is equation number 1. Students, then he applied a source of X-rays. When X-rays were bombarded on the gas inside or vacuum inside the chamber, inside the electrodes, between the electrodes, the gas became ionized. When the gas ionized, then there were produced electrons and some positive centers. E positive refers to some positive nuclei. When X-rays were bombarded on the gas or the vacuum, electrons were emitted along with the positive nuclei. You can write it as simple positive charge, or you can write it as proton, or simple symbolize it by this one. There were produced electrons as well as the positive charges. When the electrons were produced, meanwhile droplet was falling down, he applied external circuit. He closed the circuit in order to generate electric flow. Students, after the application of electric field, the negative charge struck on the oil droplet. The negative electron struck on the surface of oil droplet and moved with the velocity v2. The velocity v2 of the droplet carrying electrons with it will depend upon the strength of applied electric field as well as the weight of the droplet. Students, he observed that the velocity with which the droplet moves after the application of external electric field will be directly proportional to E minus mg. Here E is the strength, capital E is the strength of applied electric field. E is the charge on an electron, or E simply refers to the electrons, and mg refers to the weight of the droplet. Students, the velocity v2 depends upon the difference between these two parameters. If the strength of applied electric field is greater, then the droplet will move upward. If the strength of weight or value of mg or weight will be greater, if the weight of the object is greater, if the weight of the droplet is greater, then the droplet will fall down with velocity v2. And if the magnitude of these two parameters are equal to one another, then the droplet will be suspended between the space of two electrodes. Students, he calculated the velocity. Inside the chamber, there was a scale behind this vacuum. Inside the container, there was a scale on which distance or length was specified. By measuring the distance covered by the droplet in specific time interval, he was able to calculate the velocity as v is equal to d upon t or v is equal to s upon t. By using these parameters, he was able to calculate the velocities as v1 and v2. Now students, by comparing the equation number 1 and equation number 2, we will get, by comparing equation 1 and equation 2, we will get v1 upon v2 is equal to mg divided by E minus mg. Students, sign of proportionality was replaced by or is replaced by the equality at constant. Here and here will be cancelled from one another, so simply we will get v1 by v2 is equal to mg upon E minus mg. v1 and v2 were calculated by using this formula, by measuring the scale reading, by observing the scale reading inside the chamber as d upon t or s upon t. Velocity v1 and v2 were found by this manner. Now, how can we find the charge? We can find the charge by rearranging this equation. So we can write as on rearranging this equation, which is equation number 3, we will get, students, on rearranging we will get v1 cross E minus mg, which is equal to mg multiplied by v2. As we are interested in finding the charge on an electron, so we will isolate E. So E will remain here and it is mg multiplied by v2 divided by v1 is multiplied here. When it is shifted here, it will be divided here. E is multiplied here, it will be E, and this mg is being subtracted from here. When shifted here, it will be added. So we can find the charge on an electron by using this equation. E is equal to mg multiplied by v2 divided by E multiplied by v1 plus mg. Students, v1 and v2 were calculated by this method. E is the strength of applied electric field, which is known to us as we are applying this voltage. So strength of E will be known to us. And g is the acceleration due to gravity. It is a constant parameter having the value of 9.8 meters per second square. There is one thing which is mass. How can we find the mass? Students, if we have the density of the droplet and we have the radius of the circular path being created by the droplet, then we will be able to calculate the mass of the droplet. If we have the radius and density of the droplet, we can easily find the mass of the droplet. And how can we find the mass? We can find the mass by observing the scale reading. When the droplet is moving or falling under these external forces like gravity or the electric field, we observe that droplet has a spherical area. Droplet moves as a spherical ball. It has a specific radius and a diameter d. If we have the idea or information about the radius of this droplet, then we can find the volume, as well as if we have the density, then by using density and volume we can find the mass of the droplet. Now how can we find the radius? As we know that if we have the diameter, then by dividing it 2 we will get the radius r. Now the volume of the sphere will be, the volume of the spherical path will be 4 by 3 pi r cube. If we have the value of r, radius, then we can find the volume of the droplet. And if we have the density of the droplet, then by using the formula d is equal to m upon v, and on rearranging, m will be equal to d cross v. If we have the value of radius, we can easily find the volume, and if we have the density of the droplet, then by multiplying the volume with the density we will get the mass, and by putting the value of mass here we can find the charge on a droplet or charge on an electron. This is how Milliken was able to calculate the charge on an electron, and the smallest charge that he was able to calculate or that he found was E is equal to 1.59 into 10 raised to the power minus 19 coulombs. This was the smallest charge that he found, and he observed that by doubling the value of electron, by doubling the or tripling or by increasing the number of charges, means number of electrons 1, 2, 3, 4, 5 up to so on, the value of charge also doubled, tripled and so on. For example, for 1 electron it is this one, for 2 electron it will be 2 into this one, for 3 electron it will be 3 into this one. He calculated number of values, but he found that the smallest charge is equal to this one. He found that smallest charge was equal to this value. So he concluded that the electron carried this charge. Students, by the latest studies, the new and accurate value of charge on electron is 1.6 into 10 raised to the power minus 19 coulomb. This is very close to this value. In this way, we can say that the method being developed or employed by Milliken was very much effective, and he calculated very accurate charge on an electron. Students, This was the procedure which was being used and developed by Milliken in order to find the charge on an electron. Now how can we find the mass of an electron? We have another point, the mass of an electron. Students, by using the value as mass of an electron, we can find the mass of an electron by using the parameter E by m is equal to 1.7588 into 10 raised to the power 11 coulombs per kilogram. This is the charge to mass ratio. Students, we have the charge to mass ratio and we also calculated the value of charge on an electron. So we can find the mass of an electron. On rearranging this equation, we will get E upon 1.7588 into 10 raised to the power 11 coulombs per kilogram is equal to mass. Now by putting the value of E, we will get M is equal to 1.6 into 10 raised to the power minus 19 coulombs divided by 1.7588 into 10 raised to the power 11 coulombs per kilogram. Coulomb will be cancelled out with coulomb. Now we have, by dividing this we will get 0.910 multiplied by 10 raised to the power minus 30 kilogram. This minus 10 when shifted upward, it will be, when shifted here, it will be minus 11. So minus 19 minus 11 is equal to minus 30. On further simplifying, we will get 9.10 into 10 raised to the power minus 31 kg. This is the mass of an electron. Students, now you can see how we can find the charge mass or charge to mass ratio of an electron. Hopefully you have got the concept. For any query you can ask question. Thank you so much. Allah Hafiz.